Hi, I'm Martin, and in this video I'm going to talk about our work on Squeezy-Feely, where we investigate the potential of lateral thumb index pinching as an input modality. This is work I did with my co-authors Sebastian, Dominik, and Florian. The human hand can perform very precise grips that allow for fine-grained and complex manipulations and deformations of objects. Such sophistication offers vast potential for use in interactive systems, as can be seen, for instance, in pinch-to-zoom touch interfaces. Besides pinch-to-zoom, research has also started to explore grips in deformation sensing or extensively in mid-air gestures for mixed reality. As pinching with thumb and index is such a common grip, we investigate its potential for a more continuous input in human-computer interaction depending on various factors, such as the initial span of the hand. For this, we developed a study apparatus where these factors can be varied independently and performed a controlled experiment in which participants were tasked to target a value on a linear scale. Based on the results, we derive implications for future pinchable user interfaces. For the experiment, we recruited 18 participants aged between 21 and 33. We varied 5 vectors within subject that I will explain in a minute. We measured the task completion time, accuracies of participants, as well as that jitter trying to hold the target value steady, and the number of crossings before reaching the target. Additionally, we used questionnaires for further data collection. We analyzed the data mainly using 5-way repeated measures ANOVA and a logistic mixed model for accuracy. We ensured that the required force to fully compress the object, its counterforce, is equal throughout varying spans. To that end, we developed a spring-based pinchable mechanism that participants used to pinch. In the study, participants had to select the visually highlighted target cell by pinching. They confirmed reaching the target cell by pressing a clicker in their non-dominant hand. To gain a comprehensive understanding of the potential factors that influence the accuracy, efficiency, and user experience of pinchable user interfaces, we varied the following 5 independent variables. The initial grip span influences the physical distance on which a pinch interaction is performed. We vary initial grip spans based on the average span between thumb and index, and denote small as 30%, medium as 60%, and big as 90% of this span. Effectively, 30%, for instance, equal approximately 3 centimeters. Similarly, we vary the force required to pinch an object in hand based on the maximum voluntary force for lateral pinching with 0 to compare to mid-air gestures, 30 for soft and 60% for hard. We chose the maximum value of 60% to avoid exhausting participants. As the applicable force and precision may also vary with respect to the direction the object is held in, we further vary the grip direction from left to right, front to rear, and top to bottom. To get insights into the possible granularity of interaction, we then provide the different scales, the coarses consisting of 25 cells to the finest with 75 cells. Participants then had to select either a low value at 10%, a medium value at 50%, or a high value at 90% relative to each scale. We had the following 3 main research questions. The first and second one focuses on the effect of all factors on the accuracy, efficiency, and user experience while performing the visual targeting task. The third research question focuses on the ability of humans to steadily hold a certain level of pinching after reaching the target value. Because of time constraints, we can only have a short look at the results, so I'm going to focus on a few insights in this talk. You can find many more results in the paper. So in general, participants achieved an average accuracies ranging from only 50% for a small object with no counterforce in top to bottom direction, and finer scale to an impressive 100% for a big span with soft counterforce, same direction, but coarser scale. Similarly, for task completion, the times varied from 2 to 14 seconds with differences, for instance, in the span and scale used. Lastly, crossings varied a lot from nearly 0 to over 30, heavily depending on the span, grip direction, and scale. Okay, so a 5-way repeated measures ANOVA showed a significant influence of grip span on the target task completion time of participants. Post-hoc tests confirmed that the smallest span was significantly lower than both medium and big. Further, the analysis also revealed a significant influence of the grip direction. Post-hoc tests showed again significantly faster times for left to right direction compared to top to bottom. While there were no significant differences for counterforce, the scale unsurprisingly had a significant effect on the time required to complete the task, rising from the coarsest to the finest scale. For the accuracy, again, post-hoc tests confirmed that it was significantly worse for the smallest span compared to both medium and big. Also, we found significantly higher accuracy of the left to right grip direction to the top to bottom. In contrast to the findings on task completion time, the accuracy were significantly influenced by varying counterforces. Post-hoc tests confirmed here that either a soft or hard counterforce is significantly improving the accuracy compared to no counterforce at all. This is an especially interesting finding as modern mixed reality gestures are performed mid-air, which might be disadvantageous for accuracy. Again, the scale behaves as expected, with falling accuracy when the scale gets finer. To wrap up the talk, I would like to present our main finding as implications for future pinchable user interfaces. First, we have seen over almost all measures that a too small span of around 3 cm is suboptimal for a good performance. Based on our findings, we recommend to use wider spans whenever possible, as they offer a greater absolute distance per scale cell, particularly enhancing accuracy. In addition, we recommend avoiding the top to bottom direction if possible to increase overall efficiency and user experience. In cases when it is essential, designers should consider combining it only with lower scales or at least an intermediate range with a soft or hard counterforce. We also suggest the use of a soft counterforce for most situations. This is consistent with the minimum jitter measured for this level and enables users to maintain the constant target on the scale over time. When a counterforce at all is undesirable, designers of pinchable user interfaces may consider a left to right direction with a medium span at the lowest scale. Our results also indicate that the input capacity is higher than expected. While lower scales obviously improve accuracy and efficiency, we recommend not to fear high scales if they are combined with at least a medium span and soft counterforce. Thanks for watching. If you have any questions, feel free to contact me.